Welcome back. So in the last video, we explored the basics of stacks and their operations. And in this video, we're going to solve a stack problem that is a bit common. It's known as the balancing parentheses problem. And this is just common also in coding interviews as well. So how it basically looks like is imagine that you have a string that contains different types of parentheses. So you can have or other different types of parentheses. So that could be, so you might have these ones, you might, okay, that's not, okay, like that. So you might have this parentheses, you might have curly braces, you might also have the square brackets like that. And your task is to check if the parentheses in the string are balanced. And what we mean by that is that every opening parenthesis has a closing, a corresponding closing parenthesis, and in the correct order. So how a correct one would look like is it's I just use the normal parentheses. So how that would look like, you might have something like this, and you maybe have another one like that, and you have like this. So these are balanced since you can see this has a these two have a corresponding closing. This one also has a corresponding closing, this one as well, and there's also the outer one. So this is what a balanced parenthesis would look like. But now, what an unbalanced one would look like is having something like this, where you have, as you can see, you have the others are balanced, but this one does not have a corresponding opening one. Or you can also be at a point where there's an opening like this, but the corresponding closing parenthesis is missing, right? So if you're opening if you if an opening parenthesis rather, it's followed by a corresponding closing one, and then in the correct order, we consider that string to be balanced. But if that is not the case, then the string is not balanced. So the kind of steps that we need to follow to solve such a problem. The first thing is we're going to use a stack. So a stack is sort of like the best data structure to use here. The first thing we need to do is we need to traverse, and we're going to just write the steps here one by one. So actually just allow me to delete all this so you can have all the steps here. So how the steps would look like, you're going to have the first step is we're going to traverse the string, and we're going to traverse the string character by character. So while we're traversing the string character by character, if we encounter an opening parenthesis, we push it onto the stack, right? So if we encounter an opening parenthesis, let me just say if opening, then we're going to push into the stack, push into the stack. So any opening parenthesis, if you encounter an opening parenthesis, we're going to push it onto the stack. Now, when you encounter a closing parenthesis, this is going to be the third step now, which happens when you encounter a closing parenthesis. We're going to check if the top of the stack has a corresponding opening parenthesis. And if it does have an corresponding opening parenthesis, we pop it off. But if it doesn't have a corresponding opening parenthesis, we consider it unbalanced. So basically, what we do next here is, if we encounter a closing parenthesis, so I'll just say here if we encounter a closing parenthesis, we're going to check if it has a check if it has a corresponding closing. Okay, corresponding closing, and this should be closing like that. If it has and now if it has a corresponding closing, then we're going to pop it off. But if it doesn't, we're going to that means we've already known that, determined that our string is not balanced, right? And that is basically how it looks like, and we can just demonstrate this quickly. So we traverse through the string, and if we have such a string, we can have it actually in form of text here. if we have such a string, so we have, let's say we have an opening and a closing, then we have multiple openings, multiple, they should be closing, let's say three closings here, and we also have another one there, and we can add another opening here. Yeah. Okay, this should be like this. So we have another opening here. So how this looks like is we do have this two, we have these two here that look balanced. These are also balanced. If you check, they also have a corresponding closing. There's that also, and there's also this one, right? So this sort of looks balanced, yeah. And now once, how we check is we just traverse through. If we find an opening, so let's say we find this opening parenthesis. So if we find this first opening parenthesis that you can see here, this one, we're going to push it onto the stack, right? So if we have a stack on this side, it's our stack looks like this. So we're going to basically push it down here. So we're going to have our opening there. And as we continue traversing, if we find our closing, so any other opening that we have, let's say this second opening, we're also going to add it on top of the stack. And if we encounter a closing, we're going to check if it has a corresponding, or rather, if you find a closing, we're going to find if it has a corresponding opening. This, I should have updated this one here. This should be if it has a corresponding opening. Yeah. So if it has a corresponding opening, we're going to basically going to pop it off, right? And then we're going to repeat that process as we proceed until we reach the end. And that is basically how you solve the problem of balancing parentheses. Now let's go ahead and look at how you can implement this in Python. And we're just going to do it with a simple function. So we're going to have a function, you can just call it is balanced, balanced. And this is going to take in the string. So, and then, okay, I need a closing on here. And if that is the case, so the first thing that we do is after we have defined our function, we need a stack that we're going to store the opening parentheses, right? So we can define our stack here, and this stack is going to be the one that contains the opening parentheses. We're going to store the opening parentheses here. Then the next thing we're going to do is we're going to sort of map the closing to, rather, we're going to use a dictionary to map closing to opening parentheses. So it's sort of easier to sort of map them that way. So we're going to just declare, we're going to call them matching parentheses. Let me just call them like that. And it's a dictionary. And in this dictionary, we're going to define, we have a closing, and then what are corresponding. We're going to define here what a corresponding opening looks like. So a corresponding opening would look like that, right? And we do the same for the other common ones. So if you're dealing with curly braces, we have, they should be closing. Okay, like that. And we're also going to have the corresponding opening like that. Then we do the same for the square brackets as well. So for square, we have a closing, and we're going to define a corresponding opening like that. So this is what this is what it looks like, yeah. And after defining this, the next thing we're going to check now is we're going to iterate through our stack. Again, we defined that process. You're going to traverse through the string, rather not the stack. That's the string that we're passing in here. So you can just say use a for loop. You can just say for character in the string, for each character in the string, we're going to check. So if that character is in this set, that is this here. So if you have, we're going to, I remember we're checking the opening against the closing. So if it matches any of this, let's say we have a curly brace like that, if it matches any of this, Then we're going to basically append. So stack dot append, we're going to append this, pop it onto the stack, that is, or not pop but push that character to the stack. Then else if, so we're going to have another one here. So if the character is in this, so that is if the character matches any of this closing parentheses here, if it matches any of this, then the first thing we're going to first of all check is if we're going to go ahead and sort of after traversing, we just match the pairs. But if there's a mismatch, which is something that we need to consider when you're comparing with the closing, if there's a mismatch rather, or the stack is empty when you expect an opening parenthesis, that means the string is going to be, is going to be unbalanced. So how we're going to check that is just going to check if not, so for those characters, if not stuck, if not stuck, or that is now the element that is at the top of the stack there. So we just use -1 again in terms of string manipulation. I'm sure we're all aware with these operations. So if it is not equal to any of the matching parentheses that we have here, again we have all our matching parentheses here. If it is not not in the matching parentheses, that is now for every character in our matching parentheses. If that is the case, that means you found a mismatch. That means, again, if the character that we found does not match anything here, then there's a mismatch. So if there's a mismatch, we're going to return false. We'll just return false like this. So this is when there's a mismatch. But if there's not a mismatch, the most obvious thing we're going to do is we're going to pop the matching opening parentheses like we also defined here. So we're going to just pop it. So we're going to just say stack dot pop. We pop that matching parentheses like that, right? And so the stack should be empty if it is balanced. That means if the stack is not empty, because remember, if it is balanced, we are always going to pop all the other opening parentheses. We're going to be popping them off. But if it happens that the stack, even after running everything, the stack is still not empty, then that means it's not balanced. Yeah. So we're going to just return the length of the stack. So if the length of the stack is 0, you're going to just use the equivalence operator here. If the length of the stack is 0, that means that it is balanced. Just simple like that. And the next thing that we can do is we can just try and print everything out to see whether we're getting the right things here. So we'll call our function. We call our function is balanced, and we can give it a set of parentheses here. Again, it needs to be in the form of a string. So let's say we give it something like this. So as you can see here, this is obviously not going to be balanced, but let's run our code and see whether it works. So I will say Python 3 balancing. You see, it returns false. If it returns false, that means they're not balanced. But if we go ahead and let's say we have this, and we're going to have 1, 2, we balance them out like that, and then we just have this closing, and we have, let's say, the square brackets like that. Yeah. And if we run our code now, you see it returns true. If it's returning true, means that our stack, the string, rather, the string of parentheses that we gave it is balanced. So that is basically how you check everything, right? Again, you need to look at the common edge cases to test out for. So some of the common edge cases, one of them is, let's say, when you have a balanced parentheses, when you don't have a balanced parentheses, we've checked for both of those. The other one is when you just have an empty string. So if you don't have this, you have an empty string and you run it, you see what it's returning true. Yeah, it's turning true because there are no parentheses to match, so therefore it is balanced. right? So again, you can see how you can handle the edge case, probably to just tell you that there's no string and it is empty. You can just add another provision for that in the code. Yeah, so just to wrap it up from what you've seen so far, we've used a stack, the stack data structure to solve the parenthesis problem, the balancing parenthesis problem, that is. And we've leveraged the LIFO pattern, that is last in, first out, as you can see, because they're using a stack. And stacks are just perfect for such problems. And one of the other practical applications of such an operation, even the balanced parenthesis problem, is when you're maybe writing an algorithm that is going to solve all the algebraic expressions. Yeah. So if you write an algorithm like that, because you're going to be encountering some of these parentheses and everything, this is a really important step for you towards solving such a problem. Right. Thank you for watching this far. I'll see you in the next one.